Give me a while, and I'm live. Welcome to DevKami 220. And where the hell is everyone? Oh well, I'm good. Give me a while to drop the message, then I will share the news and stuff. Da 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 da. Ooh, solo there. Yep, I think the rest is solo, so I'm just going to go through the news. Da da da. And and devkami.com. Ba ba ba. 220. Then I'm going to share a few shits that's happening. Who knows? Who knows what I'm going to share today? Da da da. So, first news. Da 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 da. And. Actually, let's start with events, which I forgot about. First thing. We have not. Okay, so next week will be Ruby Tuesday as usual. No. Then yeah, that's what happened. Tristan is the one with the detail, but he's not around, so that's that. Then the news. Let me log in because there may be things I need to share. Da-da-da-da-da-da. Then I need to share my key, use security key, because that's what I use. Okay, today is Thursday, right? SB security key. Oh, okay. So I messed up the link, but let's start with this. So this is later. So this is actually the automatic reply for WhatsApp, auto reply for WhatsApp, so that you can move things away or set up auto reply for a holiday. Very useful. Don't think I'm going to use it, but let's see how it goes. So this one is this is one of those la la la. This is one of those supply chain attack. So what does it do? So essentially you have so so you can actually just create a repository that is used by an organization. The project change in name that called repo jacking. So with this way, you can just, like, for example, PyTorch recently called change name to Torch in Python. So let's say they change the repository to Torch instead of PyTorch. So some of the old code that uses PyTorch can register to it, and as a result, clone bad repo and install malware. So it works, but scary, but it works. Just be careful about repository that you install. The way to do that is actually by actually auditing your repository. Every time you change something, just have a inventory of code that you use, library that you use. So if you use a lot of code, then too bad. But if you do have multiple product and all that, then you have teams, right? So have somebody responsible for it, and every time just watch for changes of repositories and names so that you will install the package properly lah. So this one, this observatory tool, a tool from Cloudflare. Didn't test it yet, but this is something like this is just basic network tools. So when I was in on app, I actually have this thing that has dashboard, but we don't have anything around the world, so to say. What we do have is just a series of logs that say where things come from and how many people and all that. So Cloudflare can do that and then display for you. Sorry. Oh my goodness. So yeah, traditionally how you do that would be actually collect logs from your web servers, Then because you have each country have their own IP block, from there you can actually visualize the map. Then you can do speed tests, as in how long a thing is responding. And yeah, you can do all sorts of stuff with your code and all that. Cloudflare can do it easier simply because they own a lot of the edge traffic, so things that go before you. So from there, they can actually measure the traffic better and make your life easier. So next one, then this is okay. So rest in peace, John B. Andromeda. He is actually a solid-state physicist, and he is one of the reason why we use lithium-ion batteries around the world, right? So he's not the only creator, but he is one of the person that um, make it uh, make it possible for us to use it. So yeah, rest in peace and thanks for your contribution. Da-da-da. Yeah, because I'm talking alone here, things goes a bit fast and you guys are not talking. Oh well. Super exchange. Lithium ion battery. This one is messed up. This one. Okay, so this is framework in Python for you to build servers. So what you do is you can build client for this, but you can also build server from this, so that you can actually plug into your web applications. So for example, OAuth for requests. So you build your token, then you just use your auth to do requests. So yeah, I start using this because don't crowd yourself because you got a lot of mistake easily. OAuth especially have a lot of information here and there with JWT and stuff. It's a whole complex thing. So if you can let library do the work for you, it'll be better. So for example, this is a client on Django. You will use this to integrate your third-party application, Twitter, for example, all that. So yeah, this is a library for integrating all this. You can even provide a OAuth server in your application, which is actually very useful when you build an API to actually support the whole workflow. So yeah, start using it if you use Python and all that. And this one, reload. Let me reload. Oh goodness. Okay, so this Dragon. Dragon is actually so when you remember those demo you see on LinkedIn about ways for deep learning to actually change to replace Photoshop. So this is actually the model behind it. So the paper is there, but the source code is released for you to use. So it includes how to run it and all that. So yeah, it support NVIDIA for now because NVIDIA is the way for you to go. There is multiple model and all that, pre-trained weights and all that. So from links, there is human, there is LHQ. Let's open this a bit. So yeah. So either way, this is actually you need to all models requires you to actually download the weights for it to work. So yeah. Then you can run videos, all that. So yes, you want to know how things work, here's the model for you to use it with the editor, I believe. I did not test this yet, but it will work, I suppose. Okay, next. And Ethernet. Now, I have a story of Ethernet, which ultimately lead to these guys, Palo Alto Research Center. So Bob McCalf is actually one of the people that built a network in Palo Alto Research Center. He actually works as a graduate student. He actually works on ARPANET. Then as a computer research center, he actually set up ARPANET for Palo Alto Park, Xerox Park. Then from there, he actually realized the limitation of ARPANET, precursor of the internet itself. So he actually bring the technology down to office level, which is actually at that time actually compatible with the Xerox Office of the Future vision, because at that time, at the moment, people Xerox were a computer company that do not know quite what they want to do with it. To ensure the survival of the lab, they actually have the engineers and researchers who comes up with what we call what is possible from the lab, and from there create a vision called Office of the Future. The Office of the Future is one of those things that the Office of Future is one of those things that uh, give the big idea, a roadmap to creation of GUI, because Bob, there's another Bob. Damn it, he's actually the administrator that created ARPANET. So he actually believed in small machine. Uh, and what happened then is he actually funded the University of Utah to do research in computer graphic, and which lead to one of the vision of GUI. Another place where this happens is actually the lab. There's a series of lab, and there's the mother of all demo. Yeah, of all demo, which give the vision. This actually give the vision of GUI. If I can share the video, la la. It's actually a 1.5 hour demo. Oops, my video is shared on this. Give me a while. What a mess. Da display port. Yeah, it's display port. Oh well. Oh no, it's display port. I'm so sorry. This goes into Bluetooth headset. Okay, cool. This give an idea of application and all that, but after that, you build the GUI and tools that is from another research. Then the Office of the Future leads to that vision of a computer desktop, easy to use programming environment, your office application before the first spreadsheet. That again, I suddenly don't remember the name, and of course the Office Lotus further in the future. That also leads to, and because of this, they also think about a computer connecting to the printer. So another thing that comes up from the vision of, let me dig it out, is this. It's called Xerox Office of the Future part. Let's see. Da-da-da. Okay, they kind of lost it. I kind of lost it, but they have a lot of idea. Desktop networking is networking is another one, and of course this is important because you need networking to collaborate each other, and they have a new thing called the laser printer. So the laser printer is actually a technology that make printers smaller, all right, and high quality. So what happened? This is before the coming of inkjet. Inkjet is actually based on a thing called MEMS, micro electrical mechanical system. That's way in the future. The first one actually laser printer, and laser printer is one desktop size, and you need networking and all that to connect lah. So in short, Park have this to support a vision for Office of the Future. Of course, it's just that it's also because they are allowed to do research on network, as in that this Bob McCullough thinks that the net design is not adequate for small size and a certain scale, so he created it. So this article here actually talk about how it works and all that, what's the inspiration and tools, and how, because in office you need to think that a computer is not reliable. It may be off, it may be on, and you need to recover quicker, right? because in reality your computing network is on a long time. All right. So yeah, so office network need to go more resilient. So yeah, the syncing and the whole technology is very cool. Ethernet technology is actually very cool. So that's it, and that's about the news today. Let's see, SRI International. Let me share the video. Q Jack CTR. Graph. Then Firefox. Capture to here. Then where the hell? Okay. Yeah.
In what we call the Augmented Human Intellect Research Center at Stanford Research Institute. We're going to try our best to show if in your office you as an intellectual worker were supplied with a computer display backed up by a computer that was alive for you all day and was instantly responsive, instantly responsive to every action you had, how much value could you derive from that? Well, this basically characterizes what we've been pursuing for many years in what we call the Augmented Human Intellect Research Center at Stanford Research Institute. We're going to try our best to show you rather than tell you about this program.
This, by the way, is actually
Okay, there's Don Andrews' hand, Menlo Park. And in a second, we'll see the screen that he's working and the way the tracking spot moves in conjunction with movements of that mouse. I don't know why we call it a mouse. Sometimes I apologize. It started that way, and we never did change it. This characterizes the way I could sit here and look at a completely blank piece of paper. That's the way I start many projects. So with my system, that's a good start. I'll sit here and say, I'd like to load that in. So I'm putting in an entity called a statement, and that's full of other entities called words. And if I make some mistakes, I can back up a little bit. So I have a statement with some entities words, and I can do some operations on these. I can copy a word. I can say that word like copy after itself. Let's make more statements. I'll say copy that statement, and lo and behold, I have another one. Copy that one, another one. I can even copy groups of statements. I can say after that one, copy the group from there to there. And it does. So let me jump back to the head of the list, and I can do things like begin to reorganize it a little bit. Well, I say after bananas, it's more likely that I'll take the carrots there. So let me organize it by saying just generally produce. All right, produce, I've got carrots, and I'll move under there also bananas. And in fact, I could move a whole group under there, say oranges and apples also. Well, I'm going to do something called jump on a link. And a link is something that'll go between files. So what it's going to do, it says, I'm going to go to your file name, CNRO. So here's what I drew with a picture drawing capability here. It's a slight map if I start from work. And here's the route I seem to have to go to pick up all the materials. And that's my plan for getting home tonight. But if I want to, I can say, the library, what am I supposed to pick up there? I can just point to that. And oh, I see, overdue books and all. Well, there was a statement there with that name on it. So in his display, he sees my text, so I'll execute it. And sure enough, it does. But what's that running around? Well, if he's looking at my text, he'd like to have something to say about it. So we put on a marker, a tracking spot that he controls. So he's sitting in Menlo Park looking at this text, and he can point to it. But we've carefully reserved for me the right to control and operate on this. So my bug is more powerful than yours. But we can have an argument. Yeah. That's what they call a bug fight. So we've set up now audio coupling, and then we're both looking at the same display, and that'd be very handy to work. We can talk to each other and point. And maybe later I could hand you the chalk on this blackboard, like saying, here, you control it. But let's stay this mode now and add another feature that hardware-wise is available to the kind of display we have. I'd like to see you while I'm working on it. And we're going to go for a picture down in our laboratory in Menlo Park and pipe it up. Come in, Menlo Park. Hi, Bill. That's great. Now we're connected audio. You can see my work. You can point at it. I can see your face, and we can talk. So let's do some collaborating. And our forthcoming involvement is this ARPA computer network, the experimental network that's going to come into being in its first form in about a year and end up sometime later with some 20 experimental computers in a network, which would be enough so that I could be running a system in Cambridge over the network and getting the same kind of response on a CRT. And it may be that people there, the next time we have a conference in Boston, I'll try this from there. And in that network, we're going to try to develop a special service to provide network information, relevant network information for people, for the kind of information that it takes to operate such a network. Who's got what services, what protocol do I use to get there, who's up to date, how much, where's the user's guide, where can I find the paper that describes this system that so-and-so offers. That's going to be a very interesting challenge for us to utilize our tools for organizing and retrieving information.
Good morning.
Good morning.
Good morning.
You come into your office, grab a cup of coffee,
Morning, Brad.
and a Xerox machine presents your morning mail on a screen.
What's the mail this morning? This one looks interesting. Let's take a look at this. I'm going to need a couple of copies of this.
Push a button, and the words and images you see on the screen appear on paper.
Oh, thank you. Thank you, Fred. You know, Fred, I think everybody on the routing list should see this.
Push another button, and the information is sent electronically to similar units around the corner or around the world. This is an experimental office system. It's in use now at the Xerox Research Center in Palo Alto, California. Soon, Xerox systems like this will help you manage your most precious resource, information.
Anything else? Flowers. Well, what flowers? My anniversary. I forgot.
So by the way, the technology didn't get used, by the way. So what do I mean? Okay, so SRI network did not actually get used. It actually served as a research for a long time, then it just died off. Then Xerox people tried to replicate it on a project. It did not work out. They comes out with their own desktop icon and all that. Then they attempt to sell it, but then later Xerox just don't just kill off the unit and it just didn't work out. So as a result, many of the people just leave the center, and it ends up what it is lah. Of course, then there's a whole story of Apple people go in. Apple people did do their own research and did have their own idea on how the desktop work, but it is what it is lah. So I think that's about it. But last thing I'm going to show you guys. gdevelop. Can I show this? gdevelop.io. Oh damn it! Let me stop screen sharing. Password. Damn it. Okay. I think so. Show you that. Let's see. Okay, cool. Now I can share something. This is the last time I'm going to show, then I'm going to start the show early today. Yeah, the guys are busy. That happens. So, gdevelop. Okay, so what is gdevelop? Gdevelop is actually a local game development environment. It's actually very interesting because most of the game environment do not actually have visual code editor anymore. I wonder if I can show you some project. No, I don't have I have other project in other stuff, but I cannot show you that. But I'm going to show you this. Okay, template. That's not template. Okay, let's open template. I don't think I'm going to use this. Swimming's form. DevKami form. I'm going to delete this soon, probably. Create project. Now, Give Develop is a whole game development environment. It gives you all the thing that Unity provide. It gives you asset loader, asset editor. It aims to be more simple. Think Nano versus Vim, for example, right? It aims to be simpler, and it also aims to have all sort of things, variables, and all that. You can't avoid some of these things, but it aims to be simple with a GUI editor with for scene and all that. It features a local event management. So let's say you want to get something moving, you do it on event. So event is essentially if or else. If this do that, sometimes an event do not actually need if. You can just like do this. So with this you can say like enemy move in circle, enemy move square, etc. So this and you do this by adding. So you do this by having else. Then of course you have your sprites, and your sprites have behaviors. So for example, you can load asset. This is actually pixel art. You can load your PNG. You can load behavior. So behavior is something like this. Oh, they do not have behavior by default. Let me find a very good demo. This I'm probably going to delete this. Let's see whether I might delete this project because yep, delete. Let me find some good demo. Learn. Joystick control, getting started. They have a very good video, by the way. They actually have very good video, but I want to find some community made tutorial thing. Give me a while. City G develop city build it. Okay, example. Okay, here you are. La la la. Okay, cool. So you have this. Then of course you can open in your example. So there's asset. Then inside asset there's house. A house will have behaviors that they may have. Then they have a market. Again, you may have behavior, you may have not. Then you have roads. There is multiple other examples. Let me find other. There's some very good examples actually. La 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 game. La 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 GD games. La 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 G develop example. Okay. So one very thing about this game, this engine is they spend a lot of time to teach you how to do it. They have very short videos how to do things, but more importantly, they actually tell you how things work. So for example, this is how you do animation by providing multiple sprites. Then then you can set behavior. This is how your behavior on something happen, and you can do climb, fall, and all that. So each behavior have configuration. Some is easy, some is not. So essentially, GDevelop, they provide two things. They provide asset loader, animation loader, GUI level design. It works primarily 2D, but you can do 3D. It does work in 3D, but you can not just by cheating it into isometric pixels. You can do actual 3Ds. It's powered by behaviors, and more importantly, events. And you do this primary. So here's a catch. It's low code, so to say, and the reason I call this low code is because this is actually a visual coding environment. If something, then you can change, you can configure it, you can configure things, then you can configure it by, you can configure things here. I'm not going to mess around. Then you can change behavior, update checkpoint, and all that. My only complaint is once you make game as complex as Stardew Valley, for example, things get very weird very quickly. So the reason is this. How do I open my variable? There's variables. So there's global variables. There is scene variables, and each of the asset have their own variables. Okay. So for example, player have your own variables. So you can get if you do a RPG with multiple items, you get unwieldy very, very fast. But that being said, this provide an opportunity for you to low code way for you to make game, and you can publish it. People do make advanced game on this, and people do sell this game on Steam. It's just that I like it. I like it to play around. I just think that the visual scripting just get unwieldy really, really fast. So, but yeah, you should try it. It's free. It costs nothing. They do charge a percentage on asset, so they make money from there lah, and also publishing. So they do publishing and asset, but otherwise it's free. The editor alone is free. And all that. I do not know how much they charge by publishing a game, but yeah. And also it features a desktop app. You can publish the game into mobile, desktop, Linux, and even on your web actually. So for example, the reason is this preview. So can you see it? No, you can't see it. So either way, you spin up a Chrome instance for you to run your game, load your game. So it's possible for you to publish a web-only application. So with that said, I'm going to just stop today lah, because everyone is busy. It's holiday week. Enjoy yourself and don't go crazy. Or unless you want to, I'm not going to tell you how. So, all right, thanks. Leave studio, stay, then, and broadcast.